Here is round 4 of solving multi-step equations. So what we're going to do is we're just going to look at two statements, and you're going to think about, you're going to tell me what your thoughts are on these. So for the first statement, we've got 7 equals 7. The question is, when you see that statement, what do you think? Do you think that is always true, sometimes true, never true? It's always true. So when we have a statement or an equation where we end up with an end result that is always true, that tells us that we have infinitely many solutions. Let's look at that second statement. Always, sometimes, or never true. 0 equals 3. That is never true. So when we see an equation that ends up with a statement that is never true, we know there is no solution. And sometimes you hear or see this notation, which means the empty set. Let's look at example number 1. You see this equation. We're solving for x. 6x minus 5 equals 3 times 2x plus 1. So we want to get those x terms together. So our first step would be to distribute here, so we can start moving our like terms from one side to the next. So we bring that down, and when we distribute, we get 3 times 2x, 6x, and 3 times 1 is plus 3. So now let's move our like terms together. So we're going to subtract 6x. So those go away. That goes away. And I end up with negative 5. I end up with negative 5 equals 3. When is that true? Never. So what do I know about this equation? There is no solution. So here's example number 2. We are solving for x. So again, we want to combine our like terms, and we'll start by distributing the 2. So on the left side, we notice no like terms there, but here we're going to distribute. So we've got 2 times 3, that's a 6x. 2 times 1 is 2, and then plus 1 minus x. Now you might look at the right side and say, we've got some like terms. We've got 6x and minus x, and we've got 2 plus 1. So we're going to combine those. Move this up, and then 6x minus 1x is 5x, and 2 and 1 is 3. So we've got, and I think maybe you're identifying here that you've got the same thing on both sides. But let's just get those x terms together. And we see, again, identical properties. That's our reflexive property. When is 3 equal to 3? Always. And again, this is when I know that I have infinitely many solutions. So here's our last example. I just don't want you losing sight of the fact that nestled within these, you're still going to get solutions that are business as usual. So in this problem, we would still distribute, and that gives us 2 times, that's 6 minus 2x. So if I were to combine those like terms, I'm going to move that 2x over, so that goes away. So we're using our additive inverse. That's 4x plus 6 equals 6. I want to get my constants together. I'm going to subtract 6 from both sides. That leaves us with 4x equals, then we have 0 here. If I want x alone, I would divide by that coefficient, and 0 divided by 4 is 0. So this equation has a solution of x equals 0. So you'll notice in this assignment that we end up with equations that have one solution, infinitely many solutions, or no solution.